Amazing. Awesome. Okay, so the next question that we have on the menu is how to graph a natural logarithm of x. Or ln. Some people call it ln, like a lawn chair, lawn. Okay, let's say that's our main function of x. F of x is equal to ln of x. A good strategy that you can use for graphing is just to find a couple points of interest. So when x is equal to 0, we get error. And actually for logarithms, x must be greater than 0. It cannot be equal to 0. If it's equal to 0, it's not good. Very bad, very bad. So we're only going to draw on the right-hand side of the graph. So if this is our Cartesian grid here, all this end, illegal for log and ln. Okay, so that's nice. We only need to draw like basically half a graph. So, okay, if x is equal to 0, we know that this is no answer. Which means we have an asymptote, or a vertical asymptote, at x equals 0. Okay, let's say x equals 0.1. Y is going to be a natural logarithm of 0.1. In our calculators, that is going to be negative 2.303. Okay, let's say x is equal to 0.5. Like, we're going to do it all the way up to 1, and then we'll speed up. But essentially, we're trying to find some points of interest so we can start drawing the points, and then we just connect the dots. So a fairly simple strategy. So let's say at 0.5, we have natural logarithm of 0.5. Y is equal to natural logarithm 0.5. That is equal to negative 0.6931. Hope it don't tell on me. Awesome. So the next one that we have, let's say x is equal to 1. Well, what's the natural logarithm of 1? That's something that you kind of, it's a nice shortcut in the mind that you can remember. The logarithm, or natural logarithm of anything, or of base anything, of 1, that's going to be 0. Oops. It's equal to 0. Let's say x is equal to the base. The base in this case is e, which in this case is equal to 2.718, on and on and on. Y is equal to natural logarithm of the e, and that is also equal to 1. So typically when you're drawing logarithm graphs, there are two nice points that you can always rely on being there. X equals 1, y equals 0, and x equals base, y equals 1. Okay, and I think that really should give us quite a lot of the stuff that we need to just start drawing the graph. Okay, so I will draw just the right side of it, because we know the left side, when x is negative, that's kind of irrelevant. Let's get rid of this line that I put here. Technology sometimes does not cooperate, but that's okay. We can still make it work. So I'll draw that a little higher because we do have negative values. There we got x, here we got y. 1, 2, -1, -2, on and on. Here we have 1, 2, 3, 4. Okay, so let's we basically just want to fill in our points of interest. So we know at x equals 0.1, y equals -2.303. I think we can draw that just around there. That looks reasonable. Okay, now for x equals 0.5, y equals -0.6931. So just about halfway through here, and a little slightly over half closer to 1. And we know that 1, 0 is always going to be a nice point. And now we gotta look at our base. Our base is 2.718. That's the Euler's number. So that's going to have a height of 1 just around here. Okay, so with our 4 points of interest, we can pretty much just draw a line that connects them. Let's do that in blue. And we know that our line is going to pretty much follow this path on and on. And we could calculate more points of interest, but what's just important is that you have like these 2 major points of interest, like the x equals 1, y equals 0, and x equals base. So that's E. X equals the base, and y equals 1. Those are the main points of interest when you're drawing a logarithmic graph. Sounds good. Awesome. So this is our graph, and just points of interest. Gotta know them. Keep them ready. Okay, cool. And seems like they got the graph from there. It looks good. Okay, let's verify that and clear this up.